Welcome in the subject mechanical system design. Today we will discuss about the design of belt conveyor system for material handling. I am Professor A.P. Godke, Assistant Professor in SND College of Engineering and Research Center, Babulga, Yeola. So, first one is the processes in material handling system. That is nothing but the objective of material handling system. So first is the picking up the load is the first process of material handling system. Second one is the transporting the load. That is from one place to another place we can transport the load. So that will be the process. Then third one is the setting the load down. So this is the third process in the material handling system. So it is said that the best handling is the least handling. So these are the three processes included in the material handling: picking up the load, transporting the load, and setting down the load. Next, types of the loads handled by the material handling system. First one is a bulk loads that can be handled by using the material handling system. So it consists of a large number of homogeneous particles or lumps of any material is called as a bulk loads. For example, coal, then mineral ore, sand, stone. These are called as a bulk loads or examples of the bulk loads. Second one is a unit load. It is the rigid single mass handled by the transported as a one piece. So the machines or box or containers or the equipments which are handled or transported in a single unit or one piece. Such type of load is called as a unit load. Next one is the concept of containerization. The process of converting bulk loads into a unit load by using a containers is known as a containerization. Means conversion of bulk load into the unit load is called as a containerization. That is nothing but a large load is converted into a small unit using the containers is called as a containerization. Next, material handling equipments. So the purpose of the material handling equipment is a constant load travel. Then moving is nothing but the bulk or unit load. Then location, that is nothing but factories or plants. Then construction sites, then mines, ports, storage centers, etc. Then direction, according to direction, vertical direction, horizontal direction, or inclined direction. And distance, hundreds of meters or 10 hundreds of meters. So the material handling equipments are used depending on the type of the objective. That is nothing but if you want to move the material, if you want to locate the material, or depending on the location, in which direction we want to move the material, at what distance we want to move the material, at what is the purpose of move the material or transport the material. So that will be the main or prime objective of the material handling equipment. Next is the guidelines in the selection of material handling equipments. Means if you want to select the material handling equipment for transporting or picking up or for downing the load, then what are the guidelines that we will discuss here. So first, depending on the direction of load travel, then length of the load travel, then types and properties of the loads to be handled, then required load moving capacity, then characteristics of production process, then methods of stacking loads, then local conditions, and last one is the initial and operational cost. So these are the 8 guidelines are given for that we are selecting the material handling equipments. Then objectives of material handling systems. So first objective is accuracy in transporting loads to destination is the first objective. Second one is a precision in pickups loads. Then third one is a transporting loads in scheduled time. Then fourth one is a transporting loads in required time. Then fifth one is transporting loads without damage. Sixth one is a transport automation with minimum manpower. Seventh one is a low initial and operational cost. Eighth one is a simplicity and easy maintenance. And ninth one is a operational safety. So these are the objectives of material handling systems. Next one is a classification of material handling equipments. So the material handling equipments are classified in 3 categories. That is the hoisting equipments, surface and overhead equipments, and conveyors. Then hoisting equipments are further classified as hoisting machines, cranes, and elevators. Then overhead equipments are classified in trackless trucks, narrow gauge cars, overhead trackage systems, etc. Then conveyors are classified as a flat belt conveyor, true belt conveyor, a blanket belt conveyors, chain conveyors, apron conveyors, etc. Then hoisting equipments are jack, pulleys, portable hand hoist, portable power operated hoist, traveling power operated hoist, etc. Then cranes are classified as jeep cranes with rotary pillars, stationary cranes with turnable telescopic tower cranes, then EOT cranes, and then gantry cranes, etc. Then elevators are classified as cage elevators, vertical skip elevators, manually propelled stackers, etc. So this is the classification of material handling equipments. Then hoisting equipments, it is the group of device with lifting gears, then mainly used for unit loads. Then it is a vertical as well as horizontal direction material moving. Then types are hoisting machines, cranes, and elevators. Then the examples of hoisting machines are already discussed: jack, chain pulleys, rope pulleys, portable hand hoists, etc. The cranes are wall jeep crane, stationary jeep crane with rotary pillars, traveling cantilevers, wall cranes, electricity operated overheaded traveling cranes, etc. Then examples of elevators are cage elevators, vertical skip elevators, manually propelled scatters. So these are the examples of the portable jeep crane and EOT crane. This is the diagrammatic representation of the cranes or the types of the cranes. So first diagram, we are having a portable jeep crane, and second one we have a EOT crane. Then this is the hoisting arrangement for the crane. This is the bucket elevator, which is one type of a conveyor. Then types of the conveyors: flat belt conveyor, true conveyor, blanket belt conveyor, woven wire belt conveyor, chain conveyor, apron conveyor, screw conveyor. So these are the 7 type of the conveyors. Then flat belt conveyors and true belt conveyors. So this is the diagrammatic representation of the flat belt conveyor and true belt conveyor. So the belt width, effective belt width, then angle of repose you can see in the all 3 conveyors. Then second one is a true belt conveyors. There is a use of the 3 idlers or more than 3 idlers, that is a 5 idlers true belt conveyor to support the belt. So these are the flat belt and true belt conveyors. Then advantages of flat belt conveyor: so it operated over long distances, high material handling capacity, low frictional characteristics, light in weight and simple in construction, and minimum maintenance cost. Then true belt conveyor, the width of flat belt conveyor limit volumetric capacity. By giving true shape to the belt by means of the idlers, the volumetric capacity of belt can be increased. Nylon and polyester belts are used for true belt. Generally 3 idlers or 5 idler types of true belt conveyors are used. So this is the diagrammatic representation of the true belt. So you can observe here 3 idlers are used for the belt conveyor. Next one is the blanket belt conveyor used for high inclination. This is the diagrammatic representation of the blanket belt conveyor. So you can see the feed belt conveyor, blanket belt conveyor, and main belt conveyor. So for third type is the blanket belt conveyor used for high inclination. So the previous 2 types can't be used for inclination more than 35 degree. If the inclination is more, then material will slide down. In such case, blanket belt conveyor is used. It consists of a main belt conveyor and auxiliary conveyor. So the belt slope varies between 45 to 60 degree in blanket belt conveyor. Next one is a woven wire belt conveyor. So used in ovens, quenching baths, washing plants, drying paints, etc. So stainless steel and mild steel wires are used in that conveyor. So in diagram also you can see the belts conveyor or woven wire belt conveyor. Next one is a chain conveyor. It consists of a chain, that is a tail sprocket, roller chain, and then flight, driver sprocket, then carrying true and discharge gates. So this is the chain conveyors with a high efficiency, can be used as a conveyor. Next one is a screw conveyor. So you can observe one inlet is there, outlet is there, and inside there will be a screw arrangement is there for the conveying of the material. The screw conveyors can carry hot as well as the wet material. They can transport the material from fine powder to animal feed, coal to slurries, etc. Next one is apron conveyor. Apron conveyor chain. You can see in diagram, apron conveyor is there. These types of conveyors are used, constructed of a series of parallel endless roller chains running on the tracks supported by the frame. So here in this diagram, a number of rollers which are supported by the frame are arranged in a series of parallel endless roller chain running on a track supported by the frame. Usually handles heavy, large lumps and abrasive and hot material by using the apron conveyor. Then requirement of good belts, so adequate strength, good longitudinal and lateral flexibility, then high wear resistance, then freedom from ply separation, low elastic and permanent elongation, low water absorption, and least affected by moist. So these are the requirement of good belt or belt conveyor. Then component of conveyor belt. First one is a carcass. So it is the body of belt and take care of all the forces acting on it. For example, textile, fabric carcass and steel cord carcass. And second one is a rubber covers. So these are the components of conveyor belt. So in diagram you can observe the inside there will be the carcass and outside there will be the rubber cover. Then types of conveyor belt. Material. Second one is first one is a fabric plate belts. So carcass of cotton, polyester, rayon polymer, etc. Then belts thickness ranges from 5 mm to 10 mm on higher side and on lower side 2 to 5 mm with number of plies 3 to 12. Can be operated by small pulleys. Then second one is a steel cord. Thickness varies from 5 to 10 meter on higher side and lower side 2 to 5 mm. Then conveyor pulleys. A conveyor arrangement uses the following types of pulleys: driving pulley, head and tail pulleys, and second one is a snub pulleys, and third one is a idlers. Then types of drives and tail pulleys. So crown face type pulley is used, then wing type pulley is used. Lagging increases with the friction coefficient. So the two types of pulleys are there, that is a crown face pulley and a wing type of a pulley. Next one is a snub pulley to change the direction of the belt for various reasons like increasing the angle of lap on the drive and tail pulleys, facilitating the loading and unloading operations, etc. Then idlers, use of the idlers to support conveyor belt along with the load on upper run, to support the belt on lower run, to support the belt at loading point with minimum wear, to align the belt on pulleys, to give true profile to the belt, and to change the shape of the run from the true to flat. Then types of the idlers. So the roller type of idlers with ball bearing is used. So it is used for light duty application. So in this figure you can observe the roller type of the idler. Second one is a roller type of idler with roller bearing used for heavy duty application. So this is the diagrammatic representation of the roller type of the idler. Previous one is the roller type of idler with ball bearing, and this is the roller type of idler with roller bearing. Then rubber covered idlers. So it has thin rubber sleeve is provided to avoid the abrasive in case down side of the drive where dirt is present. So these are the three types of idlers used in the belt conveyor. That is the first one is a roller type of idler with ball bearing. Second one is a roller type of idler with roller bearing, and third one is a rubber covered idlers. So thank you for the watching the unit of design of belt conveyor system for material handling.